Hi, welcome. In this video, we're going to go over pointers and arrays with a memory map example. So let's get started. So let's talk a little bit about a memory map. So in your computer, you have your RAM, and when we're talking about it in terms of programming in C++, we draw it like this. This represents your memory of your computer, and it's broken into sections, and you have a memory management unit of your operating system, which puts the data into memory to be used. So a memory cell is just an area in memory that is used and has data for a program. Each area in memory would have an address. So right here, whatever data is at this location, this would be its address. And it would start at 0 and go down here. All right, so the address is just the location in actual physical memory where the data or instruction or information is stored. For our purposes, we're just dealing with data like integers, doubles, characters, or arrays of data. And we don't really care what the actual address is. We just know that each piece of data has an address. The contents, so if this is like int x, when you declare int x, your operating system will find a place to put that. So over here, this is our identifier for this integer called x. And then it has an address, that's an ampersand for the address of x. And then the contents would be, if I said x equals 10, then that's the contents that would be there, the value 10. So just to get a little idea about how a memory map works, I wanted to just go over that and explain to you. Right now we're going to focus on pointers in C++ and arrays in C++, which are actually pointers as well. And we're going to do it by looking at a memory map. All right, so let's get started. Let's talk about what a pointer is. Now when I declare int m here, if I have my memory, when I declare int m, starts at 0, then my operating system is going to find a place for m of data type integer, put the value 25 here, and m is going to have an address or a location. So this would be address of m. Now when I declare a pointer like this itemp is ready to, it gets declared, it is a pointer, it is an address, and it's ready to point to an integer, but when it gets declared like this, it's not actually pointing anywhere. It's actually waiting to point somewhere. So you have to be very careful when you declare a pointer. It is an address. It can point to an integer, and look at the other videos, but only integer pointers can point to integers, double pointers point to doubles, but this is of no use to you unless it actually points to something. Now when I declare an array, so if I say int array size 3, AR is also a pointer, but what happens here is because I've declared an array, I actually am going to point to something. So AR is going to point somewhere in memory here, and we would have AR at index 0, which is an integer, AR at index 1, which is an integer, and AR at index 2, which is an integer. So the difference between declaring a pointer, which doesn't point to anything, and declaring an array, oh, I meant to say size 3. This is size 3. If you declare an array with a size, then you will get an address and a location. So it's important to understand to distinguish between the fact that this is a pointer, but this is allocating memory, and this is a pointer, and it is not allocating memory. All right, so let's go through this. Let's again, this is just a review. We have 3 pointers here that are declared. Num pointer that points to an integer, letter pointer that could point to a character, and AMT pointer that could point to a double. When these get declared, they don't point anywhere. When this number gets declared, it's going to get allocated memory, and then I do have the ability to take one of my pointers and point it to it. There's no relationship between this name num pointer and this variable number. Those are just identifier names that I chose to make it a little clearer in this to go over this, but you could have, if you go back where we're saying item pointer can point to X, like there's no relationship between the name or identifier name of the pointer and the actual variable. So let's review about arrays. So arrays are a collection of the same type of data. So here we're declaring an array of doubles. The name of the array is X. We are getting 8 doubles. So when you do that in memory, you usually draw arrays horizontally, but in memory, you are getting X is going to point here, and this is going to be X at index 0, X at index 1, X at index 2, X at index 3, X at index 4, X at index 5, X at index 6, and X at index 7. These are all doubles, so these would be the size of doubles. And if they have data there, then this would be where their data is, 16.0, 12.0. So an array just gives you, and it's consecutive in memory, so it's contiguous, it goes in order in memory. And the way actually, if you say, C out X at index 3, which that value is at 8, and this is a 6, 2.5, 12.0, 14, negative 54.5. So if you put this instruction to C out X at index 0, your computer is going to start here at this address, and this doesn't necessarily mean it's at the beginning of your memory. This is 0 and this is some address where this array is located, and then it's going to go size of a double, size of a double, size of a double until it gets to X at index 3. So there is no guarantee that if you tried to say X at index 10, it would go size of a double, size of a double, size of a double, and then try to get to X at index 10. And you have no idea what is there. You can't assume that that's going to work. So you need to keep control. That's why we've been using static arrays, because using static arrays, you declare an array larger than what you need, and you just keep control of how many elements you're actually using in that array. All right, so here we are. We're just going to do this little animation here. I've declared 4 pointers. This is my memory map right here. Address 0 is somewhere here. It doesn't matter what the address is, because every time you execute a program, your data is going to go at a different address. And if I put one program on my computer, the data is going to be at a different address than it is on your computer. So we've declared 4 pointers here, and they don't point to anything. They do get the pointers do get allocated, but they are of no use to me in my program because they're not pointing to any usable data that's in my program. When I declare 2 numbers, so I've declared number and number 2, then I'm actually allocating memory. But notice that my pointers aren't pointing anywhere unless I tell them to. I can assign them to point there. But when I do declare number, I do get right here, this is address of number. So every time you declare a variable, I know that doesn't look like an ampersand, but that's supposed to be an ampersand. Every time you declare a variable, you can take that variable and I can say ampersand number, and that is an address. Now you can't actually do much with that address other than you can do pointer arithmetic and move it around, but you can take that address and assign it to a pointer, which I'm going to do in a minute. All right, so see, I just said here, that's exactly what I did here. I have address of number, and I'm assigning that to num pointer. So now num pointer that used to point nowhere is now pointing to this location in memory. Remember that num pointer and number, those names don't have anything related to each other. Those are just identifier names. I could have said, this could have been in X. I'm just making them related to make this a little more clear to understand, but it's not required that the name of the pointer is related to the name of the variable, but it is required that the data type of the pointer is related to the data type of the variable. Like an integer pointer can only point to an integer. So now we have, I'm assigning a location to my second pointer. So these two now have been assigned a location. And then I did the same thing here. I have letter, I declared letter X, and I assigned that pointer to my letter, and I declared amount, and I assigned that pointer to amount. So now you can see that num pointer and address of number, those are the same thing, and you can even see right here they are the same thing because there's an assignment statement there. Num2 pointer and number 2, they are the same. They are an address, they are a location in memory. Again, the location is not important. It's just the concept that it is a location. So, but they mean the same thing as far as the programming language is concerned. And then you can dereference your variables. So I can take my pointer and I can say I want to take this pointer and I want to get to its value. And this is called dereferencing. So in this example, we have two ways to access number because we did this assignment right here. I can access this number either with the variable number or with the value at num pointer. That's what dereferencing is, value at, and this word right here says dereferencing. That's reference. You are dereference. You're taking the pointer and you're getting to its value. Okay, so here this is just another slide here that says this is the address of number and this is the value at num pointer. This is the address of letter, the value at letter pointer. All right, so now we're going to do an example in the memory map with an array. So this I'm declaring an array of size 5. The data type is integer. When I declare array nums, if you remember before when I declared this pointer, if this pointer didn't point anywhere, but now it does right here, but when it first gets declared, it points nowhere. When an array first gets declared, it does get a location. Your operating system will find a location for 5 consecutive integers, and it will have a location. So array nums is an integer pointer. Num pointer is an integer pointer. Address of number is an integer pointer. Those are all of the same data type. Num pointer is an integer pointer. Address of number is an integer pointer. And array nums is an integer pointer. Number is an integer. Value at num pointer is an integer. And array nums at any index is also an integer. So in this column, they are all the same data type. And in this column, they are all the same data type. So now we can assign values to our variables. So I can say array nums at index 0 is 105. Array nums at index 1 is 362. Array nums at index 2 is 9. I can say array nums at index 3. I take the value that was array nums at index 0, which is 105. I add 3 to it, and therefore I get the value 108. And then I have array nums at index 4. And this right here, just to clarify, this is address of array nums at index 2. That is the same way that this is address of number. This is address of array nums at index 2. This is address of array nums at index 3. This is address of array nums at index 4, etc. Okay, now I can take the address of array nums at index 2, which this is a pointer to an integer, then I can assign a pointer to an integer to another pointer to an integer. Num pointer is a pointer to an integer. What that does, when you assign one pointer to another, you move the pointer. So num pointer used to point here, but because at this assignment statement, it was pointing here. But now I have a new assignment statement here, so now that pointer is moved and is now pointing here. So this is no longer the value at num pointer. This is now the value at num pointer. Yeah, this should not be here anymore. And now if I take the value at num pointer and I assign it something, it's going to go to where num pointer points, dereference that pointer. Right here is the value at num pointer, and it's going to change its value. So therefore now array nums at index 2 now has a new value.